My name is Kier. I work in Google Cloud Platform. I'm a product manager. Most of my time is spent on Cloud PubSub, which is a stream ingestion service. And I think about streaming analytics in general. So today's talk is about a story of a single company's sort of journey from self-managed stream analytics and general data analytics tools to sort of a fully managed stack. This is a picture of the team. This is a data engineering team at a company called Traveloka. As you can see, they're smiling, so this is a giveaway. The story ends well. They're happy. This is the after picture. So of course the story is really about sort of what the problem was that they faced and sort of how they fixed it. So let's dive into that. It's going to be a short talk, 10 minutes. So first of all, Traveloka. It's a travel technology firm, right? So think Kayak, Expedia, so forth. They're based in Indonesia, and they've been expanding very rapidly. They're now in 6 countries. The company is fairly large, so we're talking about 1,000 employees, 400 engineers. And what they do is they produce these apps that let you book flights and hotels, so it's an e-commerce business. Of course, when you're in an e-commerce business like this, especially a competitive one, like travel technology, data analytics is absolutely core to your competitiveness. It's not just about connecting vendors together. You have to do the right things. You have to present the right things. You have to optimize all the time. So when you're managing a data analytics stack, you're enabling use cases that are absolutely core to the business. So they were talking about basic business intelligence, right? How much money are we making? Are we making money? To kind of user-facing, high-volume features like personalization and fraud, ads optimization, cross-selling, all sorts of things. This is what the data analytics stack at Traveloka looked like before the team was smiling, the way they were in the first picture. So they ship Android and iOS apps, and they were running 2 parallel systems. Both of them were fed through an Apache Kafka cluster. An app would generate an event. It would go to a Kafka cluster they operated on AWS, and from there it was split into 2 paths. One of them was real-time. The other one was batch. You can read some more about it. They have a public blog about this, so you can get some of the details. But some features to highlight here. So the real-time things, there were 2 kinds. There was the operational database, which is Mongo. They were running it themselves. And then there was a real-time data warehouse, right? What is currently happening, which sort of fed a BI analytics tool they ran in Domo. Now, the batch use case was primarily for historical analyses, right? This is not real-time data warehousing. So you had Goblin that was reading from Kafka, and then that went into a data lake and object storage, and then it either was map reduced over through SQL on Qbol, or the BI tools were fed through Redshift. So that was the stack, and it worked. They were doing billions of events a day, so a fairly successful business. Of course, it came at a cost. First of all, Kafka is absolutely central. That's your persistence layer. Unless a piece of data makes it to Kafka, nothing works. So somebody had to be on call all the time, right? That's a cost. Secondly, you're scaling the whole thing, right? It's distributed. The company's growing fast, so throughput issues happened at different parts, particularly with Redshift. And then finally, scaling is difficult because there's so many different components of this diagram that themselves they're binaries running on multiple machines, multiple cores, right? Talking about memSQL, talking about those connectors that are themselves custom Java binaries that are taking data from Kafka, putting that into memSQL, right? So all of this needs to be administered and run, and all of this needs to be constantly scaled. And so this is, of course, cost of doing business, right? This is what you do. This is why engineers have jobs, except that at some point the cost became big enough that people started getting paged at night and on weekends, and then somebody gets paged in their honeymoon, and then they're like, okay, we're done, right? It's time for a rewrite. And so they set out for a rewrite with this goal. They wanted to turn that thing where they were scaling everything themselves into a fully managed stack that freed engineers to spend time with friends and family on weekends at nights, And then when they came to work, so they could focus on solving business problems, not running infrastructure. And sort of the core requirements were low end-to-end latency, high availability end-to-end, right, not just individual systems, and auto-scaling everything. The solution looked like this. Android and iOS apps stayed the same, the output stayed the same. Except now, the initial events went to Cloud PubSub on Google Cloud Platform, which is a stream ingestion service and a PubSub system in general. Think of it as a mix of Kinesis and SQS, if you're not familiar with Google Cloud Platform. Then all the processing, all ingestions, ETL transformation, was done in our stream processing framework called Dataflow that converged real-time streams of data as well as some legacy data that was in object storage and Google. And then we split the output into two. First of all, there was the real-time database for operations. That was migrated to AWS DynamoDB. So it's now a managed service, so that sort of achieved that goal. And all the warehousing loads went to Google Cloud BigQuery. Again, the outputs are still the same, right? So your business users don't really see the difference. So a few things to highlight about the solution. First of all the components, all the new components, right there in the middle, they're all managed. Certainly the Google bits, and so is DynamoDB. So now you don't really have to have people operating these things. Second thing to notice is that it's a cross-cloud solution, right? Even though they went all in to manage services, they were happily operating a mix. Thirdly, what you're not seeing is two different warehouses, right? Remember, they used to have a real-time warehouse, and they used to have the historical warehouse. They used to have a Kubol thing for the data analysts to run MapReduces over historical data. They had another tool in Redshift for BI dashboards. That's all gone. There's just one data warehouse. That's BigQuery. It solves all the use cases. So this is these are kind of the core sort of core features of the new solution. I think to tell you a bit more about Dataflow, right, which is the processing system. What it replaced is a lot of stuff I didn't actually show you on the initial diagram. Right, something had to consume from Kafka, something had to transform data, push it somewhere else. Dataflow does all of that. What's also interesting is that you're not transforming data in multiple environments. You're not thinking about ETL and Goblin and Spark versus custom binaries that know how to pull from Kafka and write into memSQL. It's all done with the same Apache Beam SDK that's executed and ran for you on a managed service. So that's a beautiful thing. And that's kind of, that's really the second bit. First bit I've already referred to, right? The analytics stream all went into BigQuery. Nice thing about BigQuery is that it does do real time. So you can insert something at a very high rate, just as you would essentially insert something into a Kafka log. Except it's available for analytics within a second or so. Secondly, it scales well enough. In fact, that was its original kind of promise for those giant historical queries, right? So now your analysts can go and run queries across the entirety of logs, as well as the BI dashboards that needed the latest information. They are all in the same system. What's also interesting is this developer happiness line on the last thing. So what was cool about this is, despite the fact that this is all designed for managed services, the team was able to write hermetic tests that all run locally, right? Which is kind of, it speaks to the kind of tooling that's available. So the real success story, though, is that it took 2 engineers to migrate 50 use cases in 30 days, right? They went from proof of concept to a full-scale pilot, the entirety of the data going through the system, right? There was nobody on ops. It was just two people, right? The end-to-end pipeline latency for all use cases, right? There's no longer batch and so forth. Seconds, right? As soon as the data hits PubSub, 2 seconds later it's queryable in BigQuery, whether for the BI dashboards or not. They've achieved their no-ops scalability, so hundreds of gigabytes a day. And BigQuery is an interesting bit in that because although it's a managed warehouse, because it supports your standard SQL, all of those thousands of dashboards that their business users were used to just worked, right? It was an easy migration. So that's sort of a success story about Stream Analytics on GCP. And I think it highlights kind of four attributes, is that we're open, right? Managed doesn't mean you're closed. And it is no ops, and it is scalable, and ultimately it does solve the problem. I'll be happy to answer any question afterwards. We have a booth set up there. Our first attendee gets one of these, but I'll tell you a secret. You can get a Google Cardboard for your VR experience at our booth as well. Just stop by. Thank you very much.